Hi, everyone. This is my third shot at recording this demonstration because it takes forever. So hopefully this third time will be the charm. And so I went ahead and skipped some of the steps, and I'm not going to read through the procedure because there just isn't time in 15 minutes. And I hate to do a demonstration longer than 15 minutes. So this is the fermentation lab. So you have for your materials, you are going to need a packet that says cellular respiration on the packet. But the materials for 2 labs are in this packet. So all you need out of this packet are an equal Splenda and sugar packet, and like you would get at a restaurant. So there's 3 packets, equal Splenda and sugar. And also there are 2 yeast packets, and you're just going to need 1 for this lab. And you will need a 100 milliliter graduated cylinder. You will need 4 beakers, 4 250 milliliter beakers, along with 4 pipettes for each solution. You will need glucose. You will need sucrose. And you will, like I said, you will need yeast. You're going to need a stopwatch, or you can use your phone. So I have a stopwatch because I'm in a science lab, but you can use your phone, is fine. Or the timer on your oven if you set this up on your oven. So you're also going to need some warm tap water, and so make sure you go ahead and you're close to your tap, to your faucet. I think most of you do this in your kitchen, so you should be. But you will need warm tap water. You don't want it to be scalding hot. So if your tap water, when you turn on the hot, if it comes out like really, really hot and you can't bear to touch it, make it so that it's warm and you can stand to touch it, but it's just warm, just warm enough that it's like almost too hot. You know what I mean? Or you can measure the temperature, and the temperature should be somewhere between 30 and 40 degrees Celsius, which in Fahrenheit is around body temperature, so around 98 degrees Fahrenheit. If you want to do that, but actually if you can touch it and it feels almost too hot to touch but not quite, that's perfect. Okay, you want it to be very warm, not lukewarm. You want it to be very warm, but you don't want it to be so hot that it's difficult to touch it. Okay, so the next thing that you're going to want to do is you're going to want to have 5 test tubes. I already did this one, so let me get a different set. Okay, you're going to want to make sure that you've got 5 plastic and 5 glass test tubes. And I'm not going through the steps in order because it just takes too long. So I'm just going to go ahead and tell you what I've got set up here. The steps basically tell you to set up the first beaker. You're going to label equal. You're going to pour your equal packet into the beaker and measure 100 milliliters. And you can do that just by the second mark from the bottom on your beaker is the 100 milliliter mark. So pour 100 milliliters of water in with your equal packet, stir it around, pipette in and out, and it's mixed. Do the same with your Splenda, but then for your sugar packet, you're going to add 200 milliliters of warm water. And then for your yeast, you are going to add 175. So what I did is I went up to the 150 milliliter mark on the beaker. Then I used my graduated cylinder and measured out 25 milliliters of warm water, and that made my 175. Then to do your yeast, you're going to cut open your yeast packet, take your teaspoon, which is 5 milliliters of yeast, and you're going to actually measure out a teaspoon of yeast, put it in your 200 milliliters of warm water, and this activates the yeast. The yeast are activated by the warm water. Now they will actually start carrying on cellular respiration, and well, they're not dead, but it's like they come to life. If you've ever made bread, you already know this, but a lot of people haven't made bread, I know. So once you've made those solutions, and you've got all these 5 solutions, these solutions that I'm showing you in front of me, these are what go in your 5 test tube setup. So I'm going to move them out of the way. technique that you're going to need to know how to do. You can also go to step 7 in the procedure and click on key technique, and it will show you how to do this. But I'm going to show you myself. You're going to fill up this is step 7, and this is a practice step. This is where you practice the technique, and you do it as many times as you need to. It's really not that hard. You just kind of have to do it. Have to do it right. So I'm just going to pour. You're going to fill up your plastic test tube all the way to the top. All right, I spilled some, but that's okay. But you want to go all the way to the top, as much as you can put in there without it spilling over. Then you're going to put your glass test tube over the top of that and push the plastic one up all the way as far as you can into the glass test tube. Then you're going to invert. And you will see when you do that, I'm going to come up close. That there is an air bubble, and my finger is kind of pointing at where that air bubble, where that line is for that air bubble. But you're going to have an air bubble there, and that's going to be the first measurement that you take. So practice this step as many times as you need to get that air bubble as small as possible. You want to have as little air in there as you can. The other thing that can go wrong with step 7 is that your glass, I cheated, just to let you know. I chose glass test tubes from our lab that fit, but some of your glass test tubes might not fit as well, and don't force it. If you force it, you could cut yourself. You could break your glass and cut yourself. And I don't want anybody to do that. So if your glass test tubes don't fit well over your plastic test tubes, let's say that you just have 2 glass test tubes that you can use. Well, you just have to do the experiment in steps. And so that's really a terrible option, because each time you do the experiment, it takes 2 hours. There's a 2-hour wait time. But hopefully you won't run into those kinds of problems. Any of you that are close to campus, if you don't have enough glass test tubes that fit over the plastic ones, just contact me. I'll let you borrow some glass test tubes. If you're not close to campus, you just either have to do the lab in steps, or you have to contact eScience Labs. But make sure you don't move on from step 7 until you feel comfortable with the inverting procedure. What you're doing is creating a fermentation tube. Okay, so the next thing that you're going to do is start setting up your test tubes. Test tube number 1 is going to be the glucose solution. Your glucose solution, you're going to measure 15 milliliters of glucose. In your 100 milliliter graduated cylinder. And I've already done that, so let me start over. Now, when you pour your 15 milliliters of glucose into test tube 1, it's not going to go all the way to the top. Although I must have overmeasured, because mine went a little bit too far. But you're then going to take and fill the rest of that test tube with your yeast solution. As much as you can get in there, and then do your inversion technique very carefully. And sit it in the test tube wrap. So I now have test tube 1 set up with glucose solution and yeast, and the inverting will mix the yeast with the glucose. Now I'm going to do test tube 2 with my sucrose. Same thing, 15 milliliters of the sucrose solution, but what I don't want to do is put the sucrose in the graduated cylinder without washing it first. So you want to make sure you wash the graduated cylinder in between making your test tube solutions with soap and water, okay? And so wash it very good, and then you can go on and do 15 milliliters of sucrose, and then fill up to the rest, the remainder of the space in the plastic test tube. You fill up with yeast, and then you do your inversion. So test tube 1 is glucose, test tube 2 is sucrose, and then 3, 4, and 5 are from your beakers. I forgot them. Okay, so test tube 3 is your equal solution, 4 is Splenda, 5 is the sugar solution. So these come from the beakers that we made in the beginning, the solutions that we prepared in the beginning. All right, so it's 15 milliliters of each of those solutions, and then fill to the top of the plastic test tube with your yeast. Now, you're going to let this sit for 2 hours, but it's important that you sit it in a warm place. And there's several options. One of the options that they list is they say that you can turn your oven on to 185 degrees Fahrenheit. I was thinking about that. If I was in my kitchen, my oven starts at 200. So I couldn't do that. But I'm just going to tell you, if your oven starts at 200, if the lowest temperature is 200, that's fine. Turn it on to 200. Sit your test tube rack on top of the oven, and then go ahead and set your timer for 2 hours. Let it go for 2 hours. But before you start, you need to measure where that line is. Now, personally, I think it would be great to just take a marker and mark where that line is. But you're measuring how much air is created by the fermentation, because as the yeast ferment, they're going to produce carbon dioxide gas, as well as we all know, alcohol. But please don't drink this; it will be disgusting. But the size of your air bubble is going to change, so you have to know where it started. So I'm going to try to demonstrate for you with the ruler. You want to use your millimeters, and you want to start with the 0, and you want to start it at the top, or actually you want to start it at the very bottom, which is now the top of the plastic test tube. And then you're going to measure how many millimeters it is from there. Remember to get on eye level, and I'm looking at, looks to be 6 millimeters. So it's important to be accurate. Record that number for every one of your test tubes. And then record that number in your table, and then after the 2 hours, you're going to record the amount of millimeters that the air bubble increased as it went down. So you're going to measure the air bubble at the beginning and at the end. And that's going to tell you the change in carbon dioxide gas that was produced, and that's how you're going to determine which of these solutions cause the greatest fermentation. So go ahead and set it up, do your initial measurements, and then while you're waiting for your 2 hours, you can do your pre-lab questions and your hypothesis. Your hypothesis would just be what you think is going to happen in these test tubes. Do you think fermentation will occur at all? If you think it will, do you think it will be fast, or do you think it will be slow? Which one do you think will have the greatest fermentation rate? So write this hypothesis out, and then wait and do your post-lab questions after you've made your final measurement.